We want to solve the Hamiltonian path problem. We know that it's an NP-complete problem, so we expect exponential time in the worst case. ChatGPT gives us a backtracking algorithm running in factorial time, which is bad. It's better to code in answer set programming. Even better, let's cook with ASP Chef. Chef provides several ingredients to add spiciness to your recipes. Let's start with a spreadsheet providing a selection of papers written by some authors, with their preferences and a bibliometric evaluation. We have to associate no more than 4 papers to each author, avoiding duplicates in the best possible way. We can copy the spreadsheet in the input panel. Be sure to activate the encode button, as this is not valid ASP syntax. The encoded content can now be processed to parse the comma-separated content. We obtain atoms, which can be further manipulated with a search model's ingredient. After that, select the predicates of interest and let's obtain a graphical representation. The graph is encoded in a specific predicate, and we discover that there are several communities among the authors. Let's use ASP to extract such communities, removing duplicates. We can now optimize each community, running an ASP solver on each of them. We merge the result in a single model and obtain a tabular representation that we can easily consult to drive our business. So I'm sure you are going to use ASP Chef in your next projects. Why not using also large language models? This is the Grok playground. We can specify system and user messages, in this case to extract structured data from text. If we opt for comma-separated values, we can easily address the Hamiltonian path with ASP Chef from this point. We have done all this work for you. Have a look at the new @LLMs ingredient. Configure the connection to the server, provide messages with facts, and ask for chat completion. The output is often in Markdown, and it can be easily shown with ASP Chef. Let's combine what we have seen so far. Let's ask the large language model to structure the input text using comma-separated values. We can parse them, wrangle to a relational representation, and compute a Hamiltonian path. Let's do more. Let's ask the large language model to reward the answer to obtain a more human user experience. Moving the first steps, it's quite easy. The initial point is the usual URL for ASP Chef, /s for short, /large language models LLMs. The user interface of ASP Chef will load this recipe that will introduce all the ingredients under the group large language models. And we can check the details of the documentation. Plus, we have a few suggestions on how to start. So let's have a look at this recipe: register API keys and call chat completion. So this recipe will go via the main steps that we have to do possibly only once in the browser we usually use. The first step is to go to the Grok website if we want to use that large language model server from this other place. What you have to do with the key: in the large language models register API key, you can say you can associate a key with a server URL. So we are going to use this endpoint, the default of Grok. And then we have two possibilities. We can enable a key only for the current session, or if we don't want to register the API key every time, we can register it permanently and enable in the current session. Then we can see that the next step possibly is to configure the large language model, and the next ingredient we need is the chat completion. Now this ingredient will be down here. It takes a few predicates that it's gonna interpret in some way. So in particular, the configuration will be taken from this predicate that we populated from this other ingredient. After that, we need messages for the chat completion. These messages can be stored in this predicate, whose first argument is a function with the name being the role. We can have system, user, and assistant, and then the argument is a string. The alternative is that we put the message in a specific predicate. For example, now we are providing a user message in this predicate, and the content we are going to base 64 encode with an encode ingredient. Why we may want to do this? Maybe because we have new lines and other stuff that are difficult to put in a standard ASP string. And in particular, what we can use is the mustache syntax to take data from the answer set itself. So in this case, in the input, we see that we have city with value render, and we are taking this value with this mustache query. So we are asking for the city such that the predicate city contain the value city. We will do the call to the chat completion endpoint, and the result will be put in this output predicate base 64. Now if I reload the recipe, the key is active now, and you see that we are waiting for the response from the large language model. We are getting a comma separated value in answer, and from this point we can use the usual ASP Chef elements. A very interesting use case is the possibility to interact with the documentation of ASP Chef. How we achieve this? It's very easy. Essentially, we introduced a documentation ingredient that optionally can save the documentation itself in a specific predicate. The question we are asking is essentially to give an example on the usage of merge. Then we provide with a documentation ingredient the merge documentation. We have the usual configuration and chat completion endpoint. We get an answer from the large language model that we would like to visualize with a markdown ingredients model, and here is the result. Okay. Yet another example is to use the large language model to improve the interpretability of the result we obtain with the ASP reasoning. And here we have an example about security enhanced Linux, which is a huge beast, to be honest. We are combining the elements to filter only the subject we are really interested, providing this predicate. And once we have this subject policy, objects, and an instance of an object we are actually interested, one or more, we obtain this needed policy facts. And after that, we are asking the large language model to provide answers about this policy of SE Linux. The portion of the policy itself we are obtaining from this filtered predicate that we can map back to the standard format of SE Linux rules. And then we are asking what we can do, what the subject we selected can do in the security context we specified. And we get this answer from the large language model that it's much more readable than just having a look at these single rules. Okay?